people generally ask me why Java, right? And what is Java? This is the first question that everyone gets. Okay, so if anyone asks what is Java, I would say that Java is a programming language. Okay, what do you mean by programming language? A language stands for a medium. Medium means what? By which we can communicate with each other, right? So it's a language by which you can communicate with your machines, with a dumb terminal, with a hardware, so that these machines understand what you are saying. You're providing some instructions to the machines, isn't it? But do you think that writing, understanding, or learning these programming languages is so easy? So language is a medium, right, by which we can communicate with each other, like English, like Chinese, like Hindi. So both the parties needs to have a proficiency in the language so that they can communicate seamlessly, easily with each other. So when I say programming language, this is little bit different of the normal language that I'm talking about. So by understanding these programming language, what we are going to do, we are going to communicate with computers. We are going to communicate with the hardware. So to communicate with these hardwares, we need to understand a programming language. So it's not that this is the only programming language which has been started in the past. This is all started around 1940s approximately. So if you remember, we had many different programming language during these days, isn't it? We had assembly language, a machine level language basically. A machine level language stands for instructions, a hex, a dex, a binary language, right? So everything we used to with the machines is in the binary, is in the zeros and ones. So at the end, what machines understands is only and only zeros and ones. Yes, we need to communicate with the machines by using binary language at the start in the 1940s. But that was really difficult, and understanding these zeros and ones is really difficult. It's not that easy. We are very weak with the maths. What we understand is a words, is a sentences, is a paragraphs, and we are weak with the numbers. We don't really remember numbers, right? And to store these numbers and to communicate with the machines by using these numbers is really difficult. So those were very close to the machines. COBOL, yes, assembly level language, right? So many languages we had. These were the initial languages that we have dealt with, and how we used to code is by using zeros and ones, right? This is how we used to code, and this is how we used to provide the instructions to the machines, and that was not that easy. So that's why what we come up with a procedural language. And this procedural language is also called SSAD, a structured system analysis and design. What is it? So you know about C, yes? So these are little bit on the upper side. I mean, they are not closer to the machine now. They are higher level languages. These are higher level languages. So what we are trying to do is, rather than coding directly with the machines by using zeros and ones, make a developer friendly language, make a human readable friendly language. So maybe in future you may have a programming language. You just type everything in English and program will get created. The application will get created. That may even happen. I don't know. We anyway have a natural language processing in machine learning. So that natural language processing is to communicate with the machines, right? But I'm talking about writing a logic. So we are trying to make our life easy, developers' life easy, so that we understand easily, and processing happens within the operating system, and you can provide the instructions to the machines. So with the help of these procedural languages, what we try to do is to create a standards to write a programming language. Standard to write a program, not a programming language. Standard to write a program, application. Okay, this is a standard to write a program, because there were no any standard by which you can create the applications at the start. Okay, there were no any standard by which you can create the application at the start. So procedural language says that you have to follow these standards, you have to follow these steps so that you can create the application. So let me quickly tell you. So this is a top-down approach, if you know. Procedural language is a top-down approach. Top-down approach means it's a standard by which you can create the application, right? So without standard, how everyone can be on the same page? So if you want to create applications, so try to be on the same page so that everyone follows the same standard, so that your application doesn't look like an alien code. It is easily readable by the others as well. So that's why we need to follow the standards, right? So these procedural languages were introduced in around 1970s approximately. Yeah. So where we had generally a total number of 8 steps. So I'm gonna quickly write these steps. I'm just running through this. You don't have to understand these in detail, but I'm just trying to give a clear idea about what is procedural language, just overview about procedural language. So we had 8 steps. I'm saying it's a standard, right? But standard of what? It's a standard of 8 steps that you have to follow if you want to create an application. So if you want to create an application, then you have to ask for a requirement first. So this is client requirement that will be taking care of at the start. So client will give us the requirement in a Word document, in an English Word document, we get that. So once you get the requirement, I have to convert that requirement into functional requirement. Yes. So once I get functional requirements means what? You're converting your application into functions. Assume ATM machine application. So client says, I want an application by which you can insert a card and withdraw money. So this is what the requirement client has given to us. So we said, okay. Then now we are converting this requirement into the software domain. And this thing is mainly taken care by the project leads and the architects. It's not that easy task, guys. Getting your requirement and converting that requirement into the functional requirement is not that easy. So how do we convert that into the functional requirement? What is the key aspect? I mean, what he wants. Okay, he wants an ATM machine. So what are the functions that I can think about? I can think about a function called welcome to SBI Bank, welcome to HDFC Bank. So these kind of a functions. Then maybe enter PIN number kind of a function. I hope you're getting functional requirement means what? Enter PIN number, then withdraw. So all these are what? These are functions. So I'm trying to convert my English requirement, a Word document, into the functions, into the software domain. Step 3 is to convert. So once you get the functional requirements, then understand a data that is required. Okay, a data dictionary. A data dictionary stands for what are the variables that you will be using in your application. Maybe a int for PIN number. To enter a PIN, you will require a data type, right? What are the data that you'll be using in your application? Glossary of your application. Then mapping. Mapping stands for what? Map your data with functions. How your data are going to be mapped, map with the functions. How you're going to deal with your data. What data is required in which functions. So you got your ATM PIN number, right? So this PIN number variable can be used. Can it be used in welcome? Not really. This PIN number can be used in enter PIN. This PIN number can be used in withdraw. So I'm just mapping my data with the function. So that's what mapping stands for. Then I may think of the application flow, how your application is going to run, the sequence of execution. I cannot directly ask for enter the PIN number or enter the amount. So I have to go sequentially. I need to decide the sequence by which application runs, by which application flows. Then the design. Then you'll design your application. Design means what? Design means UML diagrams. UML diagrams will represent your application in diagrams. A picture is worth of 1,000 words, right? So all the requirement which you have got, everything, whatever you have worked on your application, so everything will be represented in the picture now. Yes, a use case diagram, activity, right? ER, right? We have many types of UML diagrams that you might have heard about a long back, maybe during the college studies. right? But these diagrams are really important, really useful to create any application, to understand any application flow, structure, sequence, the number of users. These diagrams are really useful. So once our design is ready, then what we generally talk about is implementation. Yes, now we start creating our application. We start coding our application. C language, you may start coding your application, right? So once your application is ready, what we do is we test our application. So why I'm telling you this? This is a standard. So when Domino's serves a pizza, they have their recipes standardized, right? They have their recipes documented. So if their recipes are not documented, then the test of the same pizza will vary in the location to location, isn't it? So the pizza which I'm getting here in Pune, or the pizza which I'm getting maybe in Bangalore, may test different if it is not standardized, if it is not documented, isn't it? So I need to standardize everything. So in 70s we come up with some procedural language concept and the C language by which we standardize our programming languages, and we started following some standards, some steps by which we can create the application. Though it looks really nice and we started following standards, there are some loopholes. For now, I'll just introduce you why we are going towards object-oriented programming. Okay, so there were some issues in this approach. There were some loopholes in this approach. So this approach is not so flexible, not so useful nowadays. Why it is not useful, we'll discuss that. Okay, so that's why we come up with a new approach, a new way by which I can create applications. And this is one of the approach by which you can create a very flexible, robust and consistent applications, that is object-oriented programming. So there are major 4 main pillars available in object-oriented programming, that is abstraction, encapsulation, inheritance and polymorphism. Around 1990s, we come up with a new approach, that is object-oriented programming. So Java is a programming language and it also supports a object-oriented programming language. It is not procedural language. So Java is a programming language by which you can create a programs. You write down a logic, you instruct a machine. That's what programming language stands for. So you instruct a machine to perform some specific task, isn't it? And this is also object-oriented programming. We have many programming languages. We have C, we have C++, we have C#, right? We have Python, and we have Ruby and Rails. We have n number of languages. This question still remains. So the very first important thing that I can say, why Java? Java is platform independent. A very first benefit of Java is platform independent. What do you mean by platform independent now? Let's understand this in detail. So this is one of the very major deciding factor that why we should go for a Java.